whatever we had promised. We start with something called the Bertrand's paradox. This shows the inadequacy of the classical definition, which is a circular definition. So, here we will just try to solve out the Bertrand's paradox and see that it will give two different answers for the same problem, two different probabilities. So, what does this Bertrand paradox says? The Bertrand paradox says the following. So, you have a circle with a center say at O and a radius of 2 inches, and then you have a concentric circle of radius 1 inch. Two inch and 1 inch. The question is that if I randomly draw a chord in the circle, if I randomly just draw a chord in the circle, what is the probability that it intersects the inner circle? So, the question is, when does, what is the probability that a randomly drawn chord intersects the inner circle? So, what does, if you look at it, let us look at it in the following way. So, by the fact that it is intersecting the inner circle whose radius is half of the original circle, when do I see a chord is intersecting the inner circle? If the midpoint of the chord lies in the inner circle. Because you see, even in the tangent one, if this is the tangent also, does not matter, because if you join it by the radius of 1 inch, that will be perpendicular, and hence by very standard results of Euclidean geometry, you will break it up into two equal parts. So, the midpoint has to be inside the circle. So, essentially the midpoint thus can be here, 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 anywhere in this circle, and for any chord that you draw, the midpoint would be anywhere in the original circle. So, basically the probability, if I call that event as A, so let me call the event as A. Now, you observe that essentially I can say that my sample space is the space of all points in the bigger circle, all the points inside the circular disc, and my possible position of midpoints are any point here on the inner circle. So, the probability of an event A, here we have an infinite sample space, and here where the problem will come. The probability of the event A is thus the area of the inner circle, divided by the area of the outer circle. So, it is the area of the inner circle divided by the area of the outer circle. So, area of the inner circle is half of pi into 1 square, which is 1, and this is half of pi into 2 square, which is 4, right, pi r square. So, this will just give me 1/4. So, that is looks like to be a very feasible answer. Now I can look at the whole problem in a very different way, which will also appear to you as logical. So here you again take the outer circle and then draw the inner circle. So what is the meaning of a chord? So take any point, I have taken any point, I can draw infinite chords from this point, every chord need not hit the circle. So of course you can draw the diameter which is passing, a chord which is passing through the center. Now what would happen, this chord actually can vary. So from here I can just sweep 90 degrees in this direction, 90 degrees in this direction, and I can vary the chord, I can get all the possible chords. So basically I can vary this thing by an angle theta, right. So I can take any chord, if suppose this is a new position of the diameter, so I moved it by a theta angle, but this theta angle can vary between plus pi by 2 to minus pi by 2, right. It is either here or it is here. Similarly, I can say that if you look at the chord, what is the maximum amount theta can vary if the chord has to touch the circle, has to cut the inner circle. The maximum it can vary is this amount, which let us call as theta hat. Now what is theta hat? What is the maximum amount theta hat can go? So this is the maximum amount theta hat can go, starts from here, moves and comes up to here, starts from here, moves and comes out to here. So all the chords that are passing through this point. Now whatever probability I will have for the chords cutting the circle from this point, these will have the same probability, all the points. So that will be the probability of hitting, because you have to emanate from one of the points, start from one of the points. Now how much does this angle vary? So this angle you have to observe that, for example, if I draw again by Euclidean geometry, if I draw the radius of 1 inch, this would be perpendicular. So this is now 1 inch and this is 2 inch. So sine of theta is half, sine of theta hat is half. So theta hat is actually varying from, sine half is 30 degrees, theta is 30. So it is pi by 6 to okay. So all the possible angles to get the chords coming out of this point is varying from pi by 2 to minus pi by 2. And all the chords which has to be inside the circle, in the sense cutting the circle, has to have an angle variation from theta hat from pi by 6 to minus pi by 6. So then, so pi by 2 to minus pi by 2, what is the total possible angles we have? So essentially, so if I just look at this part only, which is symmetrically, it will give the same thing on the other side. So basically I am having 0 to pi by 2 possibilities on this part and 0 to pi by 6 possibilities. So probability of the same event A pi by 6 by pi by 2. So pi by 2 is the total possibilities here on this side, and pi by 6 is the possibilities that are favorable to you, and then hence this is giving me the answer 2 by 3, which is 1/3. So these two answers are varying and both of them are equally logical, looks equally logical. So this is the Bertrand's paradox, and hence that sort of approach that we had, the way we have defined probability in the circular fashion that you learn at schools, that cannot really work in general, and hence probability itself has to be thought of as some sort of function which takes an event and maps it onto a real number between 0 and 1, which follows certain property, the Kolmogorov axioms that we had studied in the last lecture. So, let us go back to the true founder, the problem of the true founder of probability, Chevalier Demer, the great gambler who gave his friend Blaise Pascal the question of how many times you get a 6 if you throw a die, one throw of a die 6 times, or two throws of a, throwing 2 dice 24 times, throwing them simultaneously. So, let us just go and solve that problem. So, this is, we have stated the problem, we will state it again. Of course, you will have practice problems with you, but this is something which you can enjoy, because that is what, how the history comes in. So, which has higher probability, that is the question. Getting 6 in 4 throws of a single die. So, first operation is trying to getting 6 in 4 throws of a single die, or number 2, getting 2 6s in 24 throws of a pair of die. A double 6 in 24 throws of a pair of die. So, what is, which has a higher probability, that is the question. So, in order to solve this, we have to use the language of complement events. So, if A is a event, A complement is the event that A has not occurred. So, if A is any event in the sigma algebra, and here you can understand in both the cases, here my omega has 6 elements. So, it is a finite set. Now, on the second one, this is omega 1, and omega 2 has 36 elements. They have the form 1 1, 1 2, 1 6, 2 1, it goes like this 2 2, 6 1, 6 6. So, it has 36 elements. So, these are having finite sample spaces. So, their sigma algebra associated with this, the U1 and U2 would be nothing but subsets of this, right. Now, here we will rely on this fact that if A is a given event, and if you consider A complement, then A union A complement, because A is a subset of omega, this will give me back the whole sample space omega. Then you know by now, hence probability of A union A omega is the A union A complement is equal to the probability of omega, and that is equal to 1, because that you know from the Kolmogorov's axiom. And hence now here again you will apply the Kolmogorov's axiom here, because these are disjoint events. So, this will immediately say that probability of A is 1 minus probability of A complement. So, what I am now going to do is to use this very idea that first I will talk about finding the probability of A complement, and then immediately you will know what is the probability of A by subtracting it from 1. So, let us see where do we start. So, let us take the first case, case 1. So, let us go by the first one. First one, let us denote by AI that the number 6 does not appear on the rolling the die for the ith time. So, AI event that number 6 does not appear in the ith time, in the ith roll of the die. Of course, I has only 4 possibilities. We will be allowed to roll the die 4 times. Now, what does it mean that I has not, the 6 has not occurred, which means any of the remaining 5 has occurred. So, probability of their occurrence is 5 by 6. So, probability of AI is 5 by 6. So, probability of 6 not occurring in the first place, first throw, and the probability that it does not appear in the second, that it does not also appear in the second throw are 2 independent events, they are not connected with each other. Now, we have not yet introduced what are independent events. So, what I am going to say, you look at it in this form that throw a die. So, what is the probability of this not occurring? 5 by 6. Again I throw a die. So, this is the probability of success is 1 by 6, the probability of failure is 5 by 6. So, I am just looking at the failures. So, if it fails at each and every time, we then if so, which means in all the 4 times I have not got a 6. So, when shall I get a 6? Is just the complementary event. So, this whole idea of independence of 2 events we have not yet discussed. But if 2 events are independent in the way as we can see it, because throwing a die now and not getting a 6 and throwing a die after 2 minutes and not getting a 6 are not connected anyway, then you multiply the probabilities. So, basically now what you do, the probability of my occurrence of the event say A hat that a 6 occurs in throw of a 4 die is 1 minus 5 by 6 to the power 4, and that turns out to be 0.518. So, you see that is how you do it. Now, you come to the case of where you are throwing a pair of die with the 36 possibilities. 6 showing up means both the cases 6 is there. So, which means if BI is the event that a double 6 does not throw up, does not show up, in the ith roll of 2 die, then what is probability of BI? So, if 6 has not occurred, 6 is just one of the occurrences. So, there are 35 other occurrences which can come. So, they are 35 into 6, 35 by 36, a number of very near 1, but still less than 1. Now, this suppose it happens for each of the 24 cases, 6 does not appear. So, then probability of B hat, that is a double 6 appears in a throw of 2 die is nothing but 1 minus 35 by 36 into 24, because each of these 24 cases are independent. So, when you have independent events, you multiply probabilities, which is something we have not told formally, which we will tell in the next class, but I did this problem because this is the historical problem. So, it is good, history is always a good guide to pedagogy. And then what should be the answer? The answer turns out to be, because of this power 24 which actually pulls down the value of this, not very far off, but this is obviously bigger, and that is what the Chevalier de Mer had actually observed in the actual gaming. When they actually played the die, actually threw the die in those casinos, he actually had seen that was their 6 was appearing much more rapidly. Now, we will talk about a very interesting and important problem called the Buffon's needle problem, and the answer to what we are going to get a fantastic answer to this problem. The probability is linked with the number pi, and that is what we are going to show. So, let us see what is Buffon's needle problem. There is a lot of writing on Buffon's needle problem, but not Buffon, but Buffon's. So, this would be the last problem. So, here once we have, you see in both the cases we have been using the Kolmogorov axioms. In the first case where you have finite number of outcomes, total outcomes, you see you can use your so called idea of proportion, the other definition. But here we need to, we will use a similar sort of definition, but here we will see how to first, when the problem comes and when you have infinite possibilities, you need to be very carefully construct the probability space. That is very, very fundamental. So, Buffon's needle problem is like this. It says that okay, let us take a plane, this plane of the board, and you are drawing parallel lines, each say 2 inches apart, 2 centimeter apart, does not matter. Each 2 inches apart. Now, you are throwing on this, say you have done it on the floor and you are throwing a 1 inch long needle on the floor randomly. So, the needle could land here, the needle could land like this, it could land like this, 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 straight touching at one point. What is the probability that the needle will cut or touch one of the parallel lines? What is that probability? How do we think about it? That's so here our first step would be to know how to, the answer is very beautiful, I do not want to tell you now, you will see when the answer comes out. So, first I have to realize how do I construct my probability space. So, my first step is to construct the probability space. And then how to use it. So, let us construct the probability space. So, here is a line and suppose here is the needle. Now, take the midpoint of the needle, see here, and find the distance of that needle from the nearest parallel line. So, of course, there could be another parallel line here, and then of course, we just look at the nearest one, and the angle that it makes with the horizontal is say theta. Okay. Now, this distance let me call x, this distance. So, x, so this whole length is 1 inch. So, what you have done, let me write down the problem clearly. In a plane, draw parallel lines two inches apart. Throw a needle of length 1 inch on the plane randomly. Throw a needle of length 1 inch throw a needle of length 1 inch on the plane. What is the probability that it touches one of the lines, parallel lines? One of the parallel lines. Okay, the writing might not be very clear, but you understand the problem. So, I have been telling, I am repeating it every time, that you have to throw the needle on the floor and see when does it touch one of these lines. So, this is the situation. So, how do I construct? So, you see this x has to be less than or equal to half to touch, because it can be in this situation. This is the midpoint and this is what. So, the angle, then this angle is of course 90 degree. So, the angle can vary from 0 to pi by 2, while this can vary from 0 to half. So, this is possible if x is less than or equal to half, bigger than or equal to 0, because the midpoint can be exactly on this line, where h becomes 0 and theta is theta, and theta is of course varying from 0 to pi by 2. So, I can define my space as so, I am now throwing it randomly. So, this is what happens under this condition on x, it will touch the line, but I am just throwing it randomly. So, my all possible outcomes need not, this is my favorable outcomes. Angle will anyway remain from 0 to whatever you throw, it is either with the horizontal, it is either 0 or it has to vary between 0 or pi by 2, either it is straight or something like that, you can always measure the angle acutely, but the length can be anywhere, the length x, that length that of the needle is between, that x can be between 0 and 1, that this x can be between 0 and half. So, this is the possibility, these are the favorable situations for hitting the line, but this length x, so I can construct this as the distance of h. So, the length x has to be between 0 and half, this is by possible possibilities, there cannot be any other possibilities, right. But the length h, where can it vary? It can vary from 0 to 1, because it could be like this, the 2 inches line and it is just lying in the middle. This is where the needle comes and hits, stops, and this is h and this is 1 inch. So, though the condition on x is 0 to half, I have my actual gameplay is happening with the two variables theta and h. So, theta can always vary between 0 and pi by 2, but h will vary between 0 and 1. Now, so I can, but the interesting part is that because I have theta and h and x is this line, the hypotenuse, I can obviously convert x in terms of h and theta. So, the favorable situation is the following, that h by h, and x is nothing but h by x is sin theta, right. So, h sin theta is equal to x. So, I can write, so my favorable situation is when h and theta is linked with this inequality. This is the favorable situation. So, I essentially my favorable event, my event that I want to find probability of in this particular problem is the collection of all theta h such that h is less than equal to half of sin theta. So, this is, so you are just translating this x less than equal to half into this, h is obviously greater than equal to 0, which we are not writing down, which is obvious anyway, h is a length, this is varying from 0 to 1. Now, this is my event. So, if I write down, so what I want can do, now how do, when you have infinite sample space, how do you really measure? One way of measuring or assigning probability is assigning the standard measure of these sets, because you see I can now find an area of the sample space, sorry I can write just omega. So, I should be able to find the area of the sample space, right, and so basically now what I am doing is I want to find the area of this and the area of this, so standard measures. So, I want to imply, let us see if I take the area of this, if I want to compute the area of this, can I use it as a probability? Of course, the area of this is positive and area of this thing. So, now how do I actually know the total number of elements here and total number of elements here? The only way of knowing is to calculate the areas, but they are infinite elements. If you want to capture the essence of total number, is essentially you have to capture it through the idea of an area. So, I find the area of this and I divide by the area of this. The area of this is of course pi by 2. So, my probability of A is area of A by area of omega. So, how do I calculate the area of A? The area of A can be easily calculated in the following way, is that you draw a line, put h and theta here, theta is along this line measured in radians, so 0 to pi by 2. So, h is equal to half sin theta, h equal to sin theta you know would be something at pi by 2, sin pi by 2 is 1. So, this is my 1, so half is half, so this is half. So, this is your half sin theta. So, h has to be below that. So, essentially my required my event is consisting of all possible points, this one, this is my A. So, how do I calculate the area of A? The area of A is simply, so area of A is nothing but 0 to pi by 2, because theta is varying from 0 to pi by 2, half sine theta d theta. Okay, so that is exactly it. Okay, so that would give me, what would be this one, half of, if I integrate sin theta, what would be, what it would, the answer that would come out is minus cos theta, which I cos pi by 2 is 0, 0, no, it is half, just a moment. So, it is 0 to pi by 2 minus cos theta sin theta. So, it is cos pi by 2 is 0 and cos 0 is 1, minus will cancel. So, it will become 1, so half. So, basically half by pi by 2, probability of A is half by pi by 2. So, the answer is 1 by pi. So, we have a very beautiful answer, the answer is 1 by pi. So, Buffon did a very interesting experiment. He took a plane like this, he drew those parallel lines and kept on dropping, say for 1000 times he kept on dropping a needle of length 1 inch and see how many times it was hitting a line. And then by doing it and increasing the number, he could get better and better estimations of pi. So, with this very beautiful example, I stop our discussion here, and in the next class we are going to talk about random variables and random vectors, their distributions, what is the meaning of independence, and some related issues. Thank you very much.